In this video, we're going to run through some basics very quickly on how to sketch the graph of an equation. Okay, and we say an equation represents some variable relationship between two variables, in this case x and y. You can see I have an example up here. So in order to sketch this, a couple things we want to do. One is we want to make a table. Tables are always good things where we plug in arbitrary values for one variable and find the values of another one. This is going to give us points on the graph. This is what this table is giving us, or solutions. Okay, we could also say that these are solutions. And then the other thing that we like to do are find intercepts. Okay, and when we mention the intercept of a graph, we are finding where it hits the axes. Okay, that's what we're looking for here. So in order to graph this variable relationship up here, the first thing I'm going to do is I am actually going to create a table of values. And so in terms of what values to plug in, of course, we always have a choice. And we can plug in arbitrary values for either x or y, and we tend to plug in arbitrary values for x. In terms of which values to plug in, we could choose a convenient one, so such as 1. We say, well, when x is 1, what would y be equal to? And what we're actually doing is we're going back and we are substituting this in for the x value here. So we'll plug in this 1 here, and we see we get this. We get 2 minus 3y equals 6. If we were to carry this up here, we have 2 minus 3y equals 6. Subtracting 2 from both sides of this equation, what you're going to notice is you actually get a 4 on the right, which is no problem. As a matter of fact, we get a y value. Oops. We're going to divide both sides of this equation by a negative 3, and we get this. We say when x is equal to 1, we got a y value of negative 4/3. So when you're graphing something, there's nothing wrong with graphing a point like this, but we see that it's pretty inconvenient. So the first thing I want to do is I actually, when working with linear equations like this one, it's a good habit to put it into y equals mx plus b form, or slope-intercept form. So the first thing we're going to do is we're going to boot this variable term over to the other side, and it's going to become negative. So we have negative 3y equals 6 minus 2x, and dividing everything by negative 3, now we end up with this expression, or this equation, y equals, well, 6 divided by negative 3 is negative 2. And this would be a positive 2/3 now, since we divided a negative by a negative. And so we have this equation right here. So in terms of graphing the rest of this, like I mentioned, we can make a table. Making a table is always a good bet. And we could see that we could plug in some x values that say are multiples of 3, because when you do that, it'll cancel out with this 3 in the denominator of this fraction here. And we'll get some convenient values instead of plugging in, say, 1. So let's say we did that. Why don't we plug in 0, we'll plug in 3, and 6. And so, for instance, if we plug in 0 now, we would get y equals negative 2 plus 2/3 times 0, which you'll see is completely going to cause that to drop out. We get y is negative 2. So we have 0, negative 2. If we plug in 3, we would have y equals negative 2 plus 2/3 times 3, and our 3's cancel out, so we have negative 2 plus 2, so we get our y value is 0. And if we were to keep going now, we'd say plug in 6. We'd say y equals negative 2 plus 2/3 times 6. The 6 and 3 cross cancel. The 6 becomes a 2. We have 2 times 2 here is our 4. And then we'd say, okay, well, that would give us negative 2 plus 4 is 2. So we'd get 2 here. And so our graph, let's talk about this. We could say we graph the points 0, negative 2. We have 3, 0. And 6, 2. And this would be a sketch of our graph right here. So now the second thing I mentioned here was finding intercepts of this graph. But you'll notice that our graph here, it hit at the points 0, negative 2 on the y-axis, and on the x-axis it hit at 3, 0. And so I just want to explore this really quickly. The thing I want to point out is any point on the x-axis has some x value but a y value of 0. And any point on the y-axis conversely has an x value of 0 and some y value. So in order to find intercepts, what we're going to do is this. Intercepts, we could find the x-intercept by doing this. Plugging in 0 for y. To find where it hits my x-axis, that'd be right here, we're going to plug in a 0 for y. And to find where it hits my x-axis, or my y-axis, which is right here, we'll plug in 0 for x. So basically, in a nutshell, we say x-intercept, we say plug 0 in for y, and solve. Okay? And we're going to do that here. We'd say, well, I had the equation y equals negative 2 plus 2/3 x. If I were to plug in 0 for y, we get this. We get 0 equals negative 2 plus 2/3 x. We could go ahead and put this 2 on this side. We get 2 equals 2/3 x. And then multiplying both sides by the reciprocal, we'd say times 3 halves, which gets these to cancel. We would say x equals 2 times 3 halves, which our 2's cancel here, and we get 3. So we say x equals 3, and we can see clearly that it hit our x-axis at 3. Okay, and so that's something we actually had on the table up here. We say this is our intercept. And since we plugged in 0 for y, this is our x-intercept. And to find the y-intercept, okay, that would be, here, we know it hits at -2. We'll plug in 0 for x. Okay, so we say y equals -2 plus 2/3, and we'll plug in a 0 for x. But that causes this term to drop out. We get -2. So it does indeed hit here. So we'd say this is our y-intercept. And after we had found the x and y intercepts, we could have just connected the dots and just sketched in the rest of the graph. So sketching graphs, make a table, also find where it hits the x and y axes. Cheers.